All right, so let's look at this problem. This problem says a ball is kicked and slides to a stop. The ball has an initial velocity of negative 4.5 meters per second, and the force of friction is 1.4 newtons. The ball has a mass of 47 grams. What is the displacement of the ball? So really what we're looking for here is displacement. So if you remember, displacement is delta x. We're looking for displacement. This is one of those variables that we've been looking at in our motion unit. Okay, so let's see what else the problem tells me. The ball has an initial velocity of negative 4.5 meters per second. Really, if the initial velocity is negative, it is just moving to the left. Since it's it's sliding right here, we just know it's horizontal movement. So that means that the ball is moving to the left. So that's what that really means. And the force of friction, so it gives us a force too. Force of friction is 1.4 newtons. It also tells us the mass of the ball, which is 47 grams. And then it's asking for the displacement. Okay, and it also tells us that the ball is kicked and slides to a stop. So if it's sliding to a stop, the final velocity is 0. All right, so I'm looking for displacement here. But just looking at this, I only have 2 motion variables. Remember, whenever we're dealing with motion, we're looking at those kinematic equations. We have to have at least 3 variables to solve for anything else. So we don't have enough information here. Now, it also tells us that the force of friction is 1.4 newtons and the mass is 47 grams. Looks like we might have enough information here to solve for something, and that something being acceleration. So we're looking for displacement, but in order to solve for displacement, I need to have another variable, and I know that in my motion equations, my 5 variables are VF, VI, displacement, time, and acceleration. So those are my 5 variables with those kinematic equations. I have VF, I have VI, I'm looking for this. I would need to have one more variable, so time or acceleration. I have enough to solve for acceleration here using my force information. So let's go back to the ball. It's being kicked to the left, and then it slides to a stop, and it has a force of friction acting on it. So force of friction is going to be in the direction opposite of the motion. And we know that the ball is sliding to a stop, which means that force of friction is really the only force I'm concerned with, because I'm not pushing the ball, I kicked it. So I kicked it, and then my force was applied, and then it's moving based on that force. However, I'm not continuing to apply a force. It's already done. So the only force I'm concerned with is the force of friction. I know that force is equal to mass times acceleration. So since force of friction is the only force I'm concerned with, I'm not looking for net. I'm not looking for the force applied here, because I kicked it, it was done. I'm not pushing it. If I was pushing the ball, that would be a different scenario. So I have my force, I have my mass, I can solve for my acceleration here. But before I can do that, I need to convert this to kilograms because we're dealing with force here. So that should actually be 0.047 kilograms. That's my mass. I need to convert this first. I can't leave it in grams. All right, so my force is 1.4. My mass is 0.047. My acceleration is unknown. So let's go ahead and solve. All right, so 1.4 divided by 0.047 gives me an acceleration of 29.9 29.78. All right, so now I have enough to solve here. All right, so if I look at my kinematic equations, I think I can use VF squared is equal to VI squared. So you might want to look up your equations to see which one would be best. But this one will work. I have VF, I have VI, I have acceleration, and I'm looking for delta x. So I only have one unknown variable here. All right, so I've selected my equation. I have enough variables here. I have A, VF, VI, so I can plug it in. VF is 0, I'm going to square that. VI is negative 4.5, square that, plus 2 times A, which is 29.78 times delta x. 0 is equal to 4.5 times 4.5 will give me positive 20.25 plus 2 times 29.78, 59.56 delta x. So I'm going to subtract 20 from both sides. Get rid of everything that doesn't have a variable. Negative 20.25 is equal to 59.56 delta x. So now I divide both sides by 59. Okay, so delta x is 20.25 divided by 59.56. I'm going to get delta x as negative 0.33 meters. Really, that just means we move to the left, which is what happened. So you will have some of these questions where you're given motion information and also force information, and you just have to take it piece by piece. In this case, we solved for acceleration using force, and then we went back to solve for the displacement. So some cases you might have to solve for the acceleration using your kinematic equations and then plug that back into your force. It just depends on what the question is asking for here. So this is an example of using kinematic equations with force.